Good morning. So for today's project, I'm going to be adding a new node to my OpenVMS cluster, which I call the Pantheon cluster. I've had a long-running tradition of naming computers after Greek mythological figures, and so currently we have 7 nodes in the cluster, and today we'll be adding the 8th. Now, I'm doing this on ESXi. So first I'm going to start by creating a new virtual machine. It's going to be running Debian. The name of the new cluster node is going to be Aries. So I'm going to call this Aries host, because within this virtual machine we'll be running SimH to emulate a Microvax 3900. So yeah, let's go ahead and get that all set up. We're going to be based on Debian 10, 64-bit. I know it's not the latest, but I find it to be quite reliable for everything we're going to need today. Okay, so Aries host Linux, Debian GNU Linux 10, 64-bit. I'm going to put it on my larger data store here. I'm going to give it 2 CPUs so that we have 1 CPU just for the emulated VAX and 1 CPU for everything else, all the Linux stuff, whatnot, so that the machine will perform as best as possible. I'm going to give it 8 gigs of memory. I'm going to give it an 80 gig, no, let's give it 120 hard disk. And now this is important. I'm going to be adding a dedicated network interface for this one to connect to, for the emulated VAX to connect to the network here. And it's important for this network adapter to be able to change MAC addresses because to support MAC address changes in the VMware network settings, because DECnet uses some trickery where it kind of rewrites the MAC address, and so that's pretty important for what we need here today, what we're doing here today. So I've got the second network adapter. I'm going to choose a data store ISO file, and I want firmware 10.5.0-AMD64. This is the one that has the proprietary firmware blobs in it. It's the unofficial ISO of that. I'm going to select that, next, and finish. Now we should see a there it is, Aries host. We'll go to that VM and start it up. I'm going to choose the graphical install. English, United States, American English. I don't know if y'all can hear it, but it's windy outside where I am. Okay, so NS192 is what we're going to use for the host communications side of things. We're going to click cancel real quick because we don't want DHCP here. And configure network manually. I'm going to go to my spreadsheet here for my infrastructure VLAN, and we're gonna put it on, let's see, 10.0.0.28, verify that that's not pingable. Okay, yeah, there's nothing running there, so 10.0.0.28. That's a class C. Or sorry, /24. I'm old, so I'm still kind of stuck in the classful networking mindset sometimes. Yep, that's the right gateway. Our DNS servers are 10.0.2.60, 10.0.2.61. Of course, all this will be different for your own setup. Call it Aries host. And my domain is chivanet.org. Set up a strong and secure root password. Mountain time. Guided use entire disk. Yes, that's what we want. Yep. All files in one partition is fine. Finish. Yes. Continue. That's going to install the base system here. We're going to configure this VM pretty minimally to begin with. We'll be adding a bunch of packages once it's all installed. Pretty soon here. Should get us to, yep, mirror selection for APT. And just go with the defaults. It's going to retrieve a bunch of index files, I guess, the database. Beg your pardon. It takes a bit. I don't have the fastest internet connection here. System D. Yay. No, don't want to participate. We Okay, so now we're at package selection. We don't want a desktop environment or a print server, but we do want an SSH server. So as you can see, we're going as pretty much as minimally as we can here. Don't need a lot of the stuff that you can select here. No point in really having a GUI on this thing, so we'll leave it text-based. It's amazing to me how fast we can install a complete Linux system nowadays. I remember when this took 40 or more floppy disks back in the days when I was using Slackware on my 486s and such. We've come a long way. It'll prompt us for where, yep, master boot record, and we're going to put it on dev SDA. No UEFI in this world. Okay, now it's probably going to reboot. Yep. Remind myself of the IP, 10.0.0.28. Okay, now we're going to go over here to my command prompt and get our SSH key over there. Now, okay, we're in. So the first thing we're going to do is su to root, and we're going to get ourselves some packages. We want build essential screen sudo emacs nox get let's see, libpcap dev. Let's see, what else? Build essential screen sudo emacs nox get libpcap dev. Libpcap is something that SimH is going to use to kind of capture that Ethernet device for our emulated VAX. Yep. You notice we did not install SimH here. It's because, for various reasons involving Debian's packaging policies, the version on the repository for Debian is, I think, SimH 3.8, and that version of SimH would require us to set up a TUNTAP device, even though we have a dedicated network interface card for our emulated VAX here. Instead, we're going to use what's called OpenSimH, which is on 4.x, I think, and it'll let us just skip the whole TUNTAP rigmarole and just capture the device directly. So now I'm going to set up sudo privileges for my user account. Sudo. So I'm just adding my user JPW to the sudo group here. as a secondary group. And then vi sudo, we're going to change this line here to no password. Write it out. Then we'll go out, come back in. So now we've got sudo going. And next I'm going to cd out to user local source, and we're going to go get okay, so we want to copy the HTTPS link here, go back to our VM, get clone, go into the directory, and then we're going to run make vax. Shouldn't take too long because we're only building one of the many simulators here. SimH actually can emulate a number of different models of VAX, but Microvax 3900 seems to be the one that most people use for just by default running VMS. It's pretty mature, pretty quick, supports a good amount of memory, so we like that. So I'm going to now, it built, so I'm going to copy ben / microvax 3900, I'll just do ben vax actually, to user local ben, now vax. Okay, so we've got the 3900 simulator. Now I'm going to create a user account for the VM to live, for the emulated VAX to live in. Put it in home Aries, give it the bash shell. Gecko's field should just be Aries. We're going to add it to the sudo group because it'll need those privileges in order to successfully capture the Ethernet device without jumping through a bunch of hoops. If you want to take this more secure, obviously there's ways to get around that, but I'm not too concerned about it myself. You are, however, responsible for the security of your own network and systems. Okay, so now we'll give Aries a password. And now I'm going to back out of here and copy my screen RC to the VM. And I'm going to edit it. And I'm going to create a new line here. Copy it because I want two screen windows for this new Aries user. One for just kind of messing around with things, and one for actually running the simulator for console access and stuff. I mean, I wish there was a really good way to run SimH in the background, but you really need the console. So I haven't really gone too far with trying to set up a systemd service or anything like that for this. But the screen works all right. Okay, so we've written that out. And now we'll just run screen. Okay, now we're in our Aries user. I'm going to make a couple of subdirectories, one for storage and one for ROM. And then we're going to copy the ka655x.bin file from user local source simh. Remember this, we built this. This is basically the firmware ROM for the Microvax 3900. I like to keep a copy of it, right in the user's directory. Well, in this ROM directory, so that it's just kind of self-contained. Okay, and now I'm gonna disconnect from my screen session. I'm gonna copy latd. I like having my hosts that have emulated DEC systems on them to have lat daemon running, because I can manage it from my DEC server if I need to. I have a VT510 out in the data shed for doing that kind of stuff. So, okay, now we need to build that. Back to user local source, tar zxvf, home jpw, latd, okay, cd latd. Oh, there. Now we need to do the usual incantation here. /configure make lots of compiler warnings, but it works. And then make install. And then we're gonna get back out of here again. And we're gonna scp/etc/systemd/system/latd.service to 10.0.0.28. This is a systemd service file that I created myself for automatically starting latd when the machine boots. So we'll move home jpw latd.service to etc systemd/system, and then system control enable latd, system control start latd. Check if it's running. Okay, yeah, it's running. So now we'll back out again and do an login-d, and we have an Aries host now. So if I do login Aries host, there's login is the lat client for Linux. So that little bit of stuff is set up now. And now I'm going to actually open a new terminal window here and SSH to one of my other. Let's just grab the NA. And then SCP. I'm going to get the INI file. We're going to put it in Aries at 10.0.0.28. Yes. We'll go back to Aries host. Back over to Aries. So we've got a DECnet.ini. Let's open that up and edit it. We're going to replace DECnet with Aries. Throughout. Actually, for now, we're going to comment that out, because that won't be correct until after we're a little further along in the install process here. So we don't need this many disks for this machine here. So I'm going to change the RQ1 disk to an RRD40. Delete this, delete this. And we're going to do that, and actually we want to zap home Aries storage vms73.iso. This is the ISO file that we're going to end up using to install VMS from. So now we have an RA92 disk in this file and an RRD40 CD-ROM attached to this file. What the zap will do is remove a footer from the ISO image, if it has one, which can happen if the image was created by a DECinfo server. I don't recall if this ISO is going to need it, but just to avoid any problems, it's worth doing. Now, here we have this attach XQ ENS224. This is what's going to determine what Ethernet interface we're going to use. So I'm going to go out and I'm going to verify that ENS224 is correct, and it is. We have it right here. It's down right now. That's that second interface we installed when we were defining the virtual machine in ESXi. So ENS224 is correct. And now, let's see, I guess we need to copy up the ISO image to Aries to Aries at Aries host : storage. I don't have it in DNS yet. Aries at 10.0.0.28. Okay, we are back. Now, I managed to copy up that VMS 7.3 ISO. Let's verify that. And LS storage. Okay, yeah. Now, so at this point, we've got everything set up to begin the install of VMS itself. So we're going to do sudo vax, and oh, hold on. Actually, we need to rename the ini file to match the name of the node, the cluster node here. And now we can run simh. So it's sudo vax aries.ini. Now what it's going to do is it's going to create this RQ0 disk, the one up here. and it's booting it. And we can see we opened OS device ENS224. This part here is important to verify, or you won't have network access. So I'm going to do a show dev, and we can see our two disks. Pardon me. DUA0 is the RA92 hard disk, and DUA1 is the RRD40 CD-ROM drive. And we're going to boot DUA1, the CD-ROM. That's the VMS installer. And by the way, you can see that the zap command actually did remove a disk type from the container on that ISO image. It would not have worked if we had not done that. It would have said that this was, it would have refused to use that ISO to boot from. So what we're going to do is we're going to boot DUA1, which is going to boot us into what's called standalone backup, a very minimal subset of VMS that only supports one command, which is the backup command. And that's what we're going to use to get a minimal VMS image onto the hard drive so that we can complete the install from there. Pardon me. Can't stop coughing today. So it's 22 February 2023, and it's 9:56 a.m. This is 24-hour time. Now it's going to go out and look for all the devices attached to the system. That'll be our hard drives, the CD-ROM drive, etc. HSC, I believe, is Hive Storage Controller. Don't quote me on that. We don't have that, and we don't have any RF disks. MSCP is DEC's Mass Storage Control Protocol, I believe. Again, we're going to be installing to a local machine here, or a local disk here, so that shouldn't matter in our case. i.e., we won't be using an MSCP device here. As you can see, it detected our DUA0 and DUA1, as well as a bunch of other things that we won't be using. I should probably look into disabling these extraneous devices in the SIMH config, but it doesn't really hurt anything for our purposes today. Now this part takes a little while. It should come up with a prompt telling us to type yes when all devices we need for the install are available. And there it is. So yes. And now we're in, excuse me, standalone backup. Now we're going to do backup, DUA1, that's our CD device, our VMS install, vms073.b/save_set. So that's the source, and then our target is DUA0. And so it's going to restore that backup to the hard drive we're going to use to boot from. As you can see, that's pretty fast. It's done now. So we say yes, and then we do Control E to get back to the SIMH prompt. And then we just type boot CPU again. Now it's going to bring us back to the dead sergeant prompt, the three greater than signs. And this time we're actually going to boot from the DUA0 instead of DUA1, now that we have minimal VMS on DUA0. Once it gets through this whole thing here. A little bit slow. Reboot. Oh, we're going to have this problem today. Okay. I've been noticing that in a lot of instances, and I don't know if it's my ESXi system or SimH or whatever, but when CPU idling is enabled in SimH, sometimes your simulated VAX just slows to a crawl. So the best way I've found to get around that is to comment out your set CPU idle. This is actually a good time to comment this out and uncomment these. Which will enable auto booting. So let's see if we get any better results now. Yeah, it's going way faster. CPU idle tries to detect when the operating system, VMS in this case, is not doing anything, so it can relinquish CPU cycles back to the host machine, which is our Debian VM here. But with these slowdown issues and the fact that this is a dedicated virtual machine just for this, I think it's worthwhile to disable it when it's causing us problems like this. Now we're going to boot from that first hard drive. It's going to prompt for the date again. And see VMS is coming up here. Detected that we have a VAX server 3900. Same thing basically as a microvax 3900. So we'll enter the date, 22 Feb 2023, and it is now 10:01. You can pretty much ignore all these errors that are happening here. That's always going to be the case when you're initially installing VMS. There's no master database for the queue manager, for instance. There's no licenses loaded. Okay, so it's asking for the volume label. Now, in a cluster, it's good practice and really kind of required in many cases to have unique system disk labels, volume labels, for each node in the cluster. It can cause serious problems up to and including being unable to join the cluster if the system disks for two machines have the same volume label. So we're going to use Aries sys, name it after the host name of our VMS system here. That's my convention. I think it works pretty well. Okay, now it wants to know where the VMS install disk is, and in our case it's on DUA1. Ready to be mounted? Yes. And I'm going to say yes to library files, yes to optional files. We definitely want online help. Take the defaults for that. I'm not interested in managing this system from an NT workstation, so we'll say no here. I'm going to go ahead and say yes for DEC Windows workstation support and 100 dots per inch video fonts. In a future video, I may show you how to get DEC Windows up through a nested X server on your Linux machine. So this will prepare us for that, although I'm not going to cover that in this particular video. We don't want DECnet Plus. It's a royal pain to configure and probably overkill for what we're doing here. We do want DECnet Phase 4. That's the older version. DECnet Plus, also called DECnet Phase 5, implements the OSI network standard, and it's very complex. There are a lot of requirements for, I think you have to have some kind of, you have to plan some kind of node directory and other things. I've never managed to do it, so we'll stick with phase 4 here. That's all good. Our disk is more than big enough to handle everything we're throwing at it here. So now it'll install everything we selected. Doesn't really take too long. Yes, it's installing DECnet, and yes, we want Deck Windows Motif as the default windowing system. Set a password for the system account here. Systest. And field. If I recall, the OpenVMS on the alpha only asks for the system password. Don't quote me on that. SCS node name. This is our host name. Now, in VMS, this is limited to 6 characters. So with my theme of Greek mythological figures, I look at the Wikipedia list for that, and I reserve any that are 6 characters or less for VMS and DECnet sorts of machines in particular. In our case, this is Aries. SCS system ID. Now this is calculated from our DECnet address. So I'm going to go to my handy dandy little spreadsheet over here, DECnet, and Aries is going to be this one. So our SCS system ID is 1032. I forget what the calculation is to determine your SCS system ID from your DECnet address, but it's easy to find that online. So now it's configuring all the devices that are available. And then I think it's probably going to ask if I want to register product authorization keys, and I do not. Hold on a sec. I'm going to quit Slack there. And I do not. We're going to do that later. So we're in the US. That's correct. I'm in Mountain Time. Not in Daylight Savings Time. That's the correct TDF. Yes. So now it's going to do a sysgen on this machine, and then it will reboot. Yep. There's a lot to shut down and to start up, for that matter, in VMS, so it takes a bit. Much faster than on any real VAX, though. Ironically, one of these emulated VAXs on my fast Xeon-based server in ESXi is much faster than VMS on my real alpha. So that tells you something. Now we're booting into the installed system, the fully installed system, for the first time. Okay. And we are in. Okay. So the next thing that I need to do here is register product authorization keys, basically the licensing for this stuff. Now, unfortunately, since HP dropped the OpenVMS hobbyist program and VSI did not buy the rights for VMS on VAX, there is not an easy way to legally obtain licenses for VMS on the VAX. I do not condone software piracy in any way, shape, or form. When we do that, I think we tend to damage the reputation of the hobbyist community as a whole, and that provides a disincentive for companies like VSI or HP or whoever else to even bother with hobbyist licenses. This situation sucks, I'm not going to lie, but suffice it to say that I am not a lawyer, and neither do I play one on TV or on the internet or YouTube for that matter. But you will need to legally obtain licenses for VAX VMS, VMS cluster, VAX cluster, DECnet VAX, VolShad, which is volume shadowing, and either DVNet End or DVNet RTG, depending on whether you want to run your machine as a routing node or a non-routing node, DECnet-wise, and also UCX if you want TCP/IP. I don't know what the licenses are for multi-net or TCP/ware. I've never really used any of those, and probably, since 2001 or something. I used to have an actual physical media kit for multi-net. And that's a really nice system, but, DEC TCP/IP for VAX, formerly known as UCX, is pretty good. Anyhow, I am going to stop the video once more and get those licenses loaded up. And then we'll come back and continue our configuration. Okay, we're back. We have our licenses loaded now. You don't want to share those with anybody. It encourages software piracy. So now, anyway, the next thing we're going to have to do is take a look at our sysgen parameters to make sure we're ready for DECnet and TCP/IP and clustering and all that good stuff. So in VMS, I'm going to be doing a lot of copy pasting here from a working instance. It's just easier that way. But that can be a little tough in VMS if you don't have your terminal settings right. It has a very limited type ahead buffer, and pasting into a terminal emulator for our emulated VAX here can easily lead to these data overrun errors, can mess up our configuration files and everything. So what we want to do is do set term /VT100, so it's a VT100 terminal, and we want insert. That'll allow us to do insert editing on the command line, And we also want host sync. Host sync will, I believe, use X on, X off to prevent those data overrun errors. You can still get them, but they'll be far more rare. And this will prepare us for editing things. So now we're going to edit sys$system : mod params .dat. We're going to put our stuff down here at the bottom. Meanwhile, I'm going to connect to a working system here to get the correct parameters. Do type / page sys$system : mod params .dat. And we need, at this point, we just need these. This is going to increase some memory allocations. It's kind of like doing, what is it? Syscontrol tuning in Linux, you know, the shared memory stuff. Kind of the same idea. So anyway, we'll go ahead and add those to our new Aries system here. Write that out with Control-Z. And now we need to do a new sysgen, which means we run sys $update : autogen get data reboot no feedback. And this is going to take what we just entered in that file and sort of commit it to the system so that we have the proper configuration here. It does involve a reboot, unfortunately, but shouldn't take too long. In our Aries.ini, we have set CPU 64M. That means we gave this machine 64 megs of memory, which is more than enough to handle the additional allocations of global sections and whatnot that we added to our mod params.dat. I believe the next thing we will do is configure DECnet. And I know for a fact that I am going to fat finger this. I think it's sys$system : netconfig. If it's not sys$system, it's probably sys$manager. Yeah. There we go. Aries is our net name, our node name. Then go back to our little spreadsheet. It's 1.8 is our DECnet address. Don't want to operate as a router. Pretty much take the defaults. Now it's going to generate a big old DCL script and show it to us. And yes, we want these commands to be executed. We have the license keys loaded, so we can say yes here. And pretty soon, yep, the circuit's up and we should start seeing some adjacencies. Yep, that's my Cisco router, the adjacent node that we're seeing here. And here we're seeing where the interface came up. So that's good. I'm going to do our little terminal incantation here. And we're going to go ahead and edit sys$startup sy startup underscore vms.com and set it up so that DECnet gets started automatically when the system starts up. And we use the second one because we don't have batch queues running, and I don't bother with it even when we do. I'll do show net. You can see we have one network running, and that's DECnet, and our address is 1.8. So now the part you've all been waiting for. We're gonna join Aries to the cluster. I think it's at sys$system cluster underscore config underscore LAN. Once again, manager. Add Aries to existing cluster. Yes, the LAN will be used for cluster communications. The group number for my cluster is 1. Put in my strong and secure password. If you get that reference, cool. It's not going to be a boot server. It will be a disk server. No RF disks. And the allo class parameter. See, our DECnet address is 1.8. So I use that second number as the allo class parameter. Now, what allo class is when you have a cluster with multiple systems that may potentially have the same device names for shared disks. It differentiates them by putting $, then the allo class value, $, and then the device. So for instance, on this machine, DUA0 would be referred to as $8 $DUA0 : So it's just sort of a disambiguating thing, essentially. There's a little more to it than that, but that's the gist of things here. The cluster does not contain a quorum disk because we're not using shared storage in this case. We don't have DSSI or whatever, and I don't want to get into quorum disks. And no, we don't want to run autogen now. That would reboot, and there's a couple of things I want to change in the modparams.dat before we do an autogen and reboot and all that nonsense. So make sure my terminal's right. I'm sure it is, but now, so we edit sys$system : modparams.dat. And at this point, I want to change it. This node does not get a vote because it doesn't participate in the shadowed volumes that have the common cluster things on them. So the way I like to do things is, or the way I've set up this cluster anyway, is we have 3 cluster nodes that all have basically a mirrored, or in VMS parlance, shadowed volume. And there's one for user data and one for other things that are shared cluster wide. And so that means we have some redundancy. So what I do is I set expected votes to 2. If the number of votes in the cluster don't match expected votes, then all I/O activity gets blocked until there's enough votes to constitute a quorum. That's what that's called. So only the cluster nodes that participate in our shadow sets get a vote. We have 3 nodes that have 1 vote each. So if the votes drops below 2, we know we have lost all redundancy for our shadow sets, and that's when I want to block I/O. Since this machine will not participate in the shadow sets other than mounting them remotely, we're going to not give it a vote. Makes sense. And I think everything else looks good here. Although I do want to set shadowing is 2. That's sort of which version of shadowing we have. That's the shadowing mode for volume shadowing. And then we do shadow max copy is 128 because we have lots of I/O bandwidth on this fast VM here. Kind of determines how fast synchronization of shadow sets is going to go. I think 128 is the maximum value. So that looks good. Votes equals 0. Expected votes equals 2. And now we can sysgen. Sys $update, autogen, get data, reboot, no feedback. You can tell it's later in the morning because I've switched from coffee to Kool-Aid in my pretty Starbucks cup. Isn't that cute? And this time, if we've done everything right, when the node reboots, it should join the cluster. It's rebooting. Yep. Sending a VAX cluster membership request to system Hypnos, now a VAX cluster member system Aries. So we've joined the cluster now. And you notice that it didn't ask for the date again, any of those subsequent reboots. Probably going to, oh, yeah, it warned us that there's multiple different versions of VMS in the cluster. So we have an alpha that's on 8.3. DECnet's coming up. That's good. Any minute here we should be able to actually get a login prompt. Yeah, coffee and Kool-Aid are sort of my weaknesses. Ah, here we go. Took a while. So straight away, very first thing, we're going to do our little terminal incantation. Once this is all configured, we'll be on a shared sort of automatic login.com script that will set this for us. But for now, we're just doing it manually each time. So the next thing we want to do is make it so that things like the user authorization file, UAF, sysuaf.dat, I think it's called, the NetNode database, proxy databases, queue manager, all that stuff is accessed through the shadow set that has the config that's common to the entire cluster. what this will allow is a single authentication database, so that we add an account in one place and it's accessible from every node in the cluster. It's kind of the point. With a properly configured cluster, it shouldn't really matter what particular node you log into. Everything should appear the same. It might be a little slower or a little bit faster, but yeah, so we have to define some logical names that repoint things to the common cluster configuration. But first we want to verify that we can actually mount the shadow set that has all that stuff. So I went over to one of my already configured nodes here. Get all that off the screen. Now I'm going to do type / actually, for this we need another terminal incantation. The lines in this configuration file are kind of long and we don't want them to wrap. So we need to make our terminal a little bit wider to make this process way easier on us. So I'm going to do set term / vt100 / insert / host sync / width equals 132, and I'm going to actually go ahead and copy that. Okay, yeah. And then do the same over here. And then over here we're going to type /page sys$startup : sylogicals.com. Okay, now we're going to go down to this point here, and you can see these mount commands. This sylogicals DCL script runs very early in the startup process, and that's a necessity when we're talking about shared cluster configurations. We need access to these two highlighted shadow sets very early in the boot process, especially shadow data. So that's why we use this rather than sy_startup_vms.com. So now we're going to edit that same file on our new node. Edit sys$startup : sylogicals.com. Actually, no. First, we are going to try those mounts. If we can't mount those disks and we actually go ahead and make these changes, we're going to be in a world of hurt, and we're going to have to do a bunch of magic sort of recovery mode boot incantations to fix it. So we want to make sure that we can actually mount these things first. Yep. And yep. So we're good. So let's edit sys$startup : sylogicals.com. We're going to page down to here, where all these define /system /executive commands are. We're going to add our mount commands, and then just bit by bit, we're going to copy the correct stuff over. There's probably an easier way to do this, but I'm really not all that good with the editor. So sysalf.dat was the last one. I'll get like 3 more. Like I said, host sync prevents most data overrun errors, but not all. So that's why I'm doing it a little bit at a time and not all in one swell foop. If you've been doing this for a while, you probably recognize, or you may recognize that this basic setup comes from the vinalboom.org blog. Got to give him credit for this. And I've made a few little changes here and there, but on the whole, this comes directly from that. Although I have more nodes, and I'm using a three-member shadow set in both cases, where he only uses two. And I think my volume names are actually the same. So we're set there. I think that's good. Now, moment of truth. We are going to reboot, and hopefully we come up successfully with a shared config. Now, unfortunately, we're going to have to go in and rerun our DECnet config, because when you switch to the shared config, for some reason, it thinks that the DECnet node name and the system node name don't match. I'm not sure why that is. Maybe you can tell me in the comments if you're a more seasoned expert than I am, which many people are. But let's go ahead and try this. I see no reason why it shouldn't work. I hesitate a little bit on this step, because if you mess up sylogicals.com and try to reboot, you're not getting back in. Just a word of warning. You want to really work on getting this right. Dismounting those shadow sets. Moment of truth. It should say something about loading MSCP, and then it should mount those shadow sets. And I can test it once everything comes up by attempting to log in with my own personal account, which is on the shared authentication database. Okay, we joined the cluster, that's good. We should pretty soon, like right after this, we should be mounting those two shadow sets. And that's the most important thing. Everything after that will fail if that doesn't work. Okay, we mounted shadow data. That's really the crucial one. Okay, this is good. DECnet should fail. Yep, DECnet node name, local node must match VAX cluster node name. Why it doesn't, or why it thinks it doesn't, I have no idea. But once it lets us in, we'll fix that. Not hard. Since VMS is using, I believe, using the LAN in the raw, Ethernet in the raw, to do cluster communications. Well, I mean, it has to be, because DECnet was not up when it managed to join the cluster. I should probably wait to configure DECnet until after this step to prevent this problem. But, oh well, it's not difficult to fix. We just run. See if I get that right this time. Sysmanager net config. Yes. Yep. Yep. See, it already knows everything that we put in. Purge the object database. Notice that the network object database file is over here. You know, that's why. Yeah, we should be, you know, we should have configured DECnet after we joined the cluster. Because of course, the network object database file that it put all this stuff into was on the local system. Since we've switched to using this shadow data volume here to hold all that stuff, of course it's not in there. Generate your DCL. Yep. Yes. And this is basically a idempotent, so doesn't really hurt to make these accounts again for DECnet. Yep, license key is already registered. So now DECnet should actually succeed. Yep, DECnet's back up again. And now, let's see, what do I want to do next? We are going to create the proxy next to allow ourselves on this node to access stuff, or allow everyone else in the cluster to access stuff on this node. So we're going to do setdef shadow data cluster $config. I believe when you run the authorize utility, you need to be in the directory where sysuaf.dat is. I think I read that somewhere. So I always do it. I'm probably wrong about that. We run mc authorize. So now we're in UAF. We're going to do add/proxy. Then our node name, ****/def. Okay. And then I'm going to do a list/proxy or just list proxy? Well, we'll find out. Exit type, let's see, type netproxy.lis. Okay, so we've got that. Now we're going to do mc_ncp on the network control program, and we're going to copy the node database. Copy known nodes from Aries to all. All. It's not all. It's both. Show known nodes. And of course, this is the executor node, so of course that's correct. Let's get out of here and then do mc_ncp on this side on the other node and do show known nodes. Okay, that's odd. Copy known nodes from Aries to both. Oh. Copy known node. Yeah, I did it on the wrong side. I'm really dumb. From 1.8, that's our new node, to both. Show known nodes. There we go. Now so we've got our proxy, and we've got our node database updated. So now the next thing is going to be Let's see, what should we do? Let's get the queue manager going. I should have done this before. Sys dollar startup colon, this is on the existing node. We're going to change sylogicals.com again. Okay, so we need to copy this line. This is going to tell our new node where the master database for the queue manager is going to be. Add that file in the same spot where it was on the other node. And we're going to actually run that here so we don't have to reboot right away. And then we're going to edit our sy startup _vms.com file. And we're going to uncomment the line that says enable auto start /queues, so it will enable queues that are defined as auto start. It's right here. Write that out. Now we should be able to do start /queue/manager and then show queue. Yep, there's all of our queues. And then the next thing I want to do is let's get lat going. I don't really know why that's not a default thing. So on our other node, let's get out of this file, then system sy startup _vms.com. Run all the way down to the bottom, and we're going to copy all this stuff, and then all the way to the bottom, paste it on the new node, and we're going to comment out Pathworks because I'm not going to be running Pathworks here, and I'm not going to be running DSM here just yet, and we don't want those things to fail. Copy these two lines, then run those. Okay, and then I'm going to do mc-latcp, it's the lat control program, and I'm going to do show services. Okay, and then I want to create a couple of new services here. I think it's create service /identifier is Pantheon. I'm just going to use ident equals Pantheon cluster Pantheon. Let's see if I got that syntax right. Looks like I did. Yay! And then that's a service that's defined on every cluster node. So when you login or lat login or use the terminal server to Pantheon, you'll just get any node in the cluster that happens to be, I think, the least busy. And then I'm going to do another one. Vax nodes. Vax. So you can selectively log into only a Vax node. There are things that I have another one for alpha too. I have some applications that only run on VAX and some that only run on alpha, so this is kind of useful that way. And now I'll do show services again. There we go. I think we're good there. And now, let's see. Guess we can install TCP/IP. Making good progress here. So we're going to go to our CD-ROM drive, set def DUA1, I think it was, root directory. So 6 zeros represents the root directory. It's probably not mounted. Yeah, it's not. So mount / over equals ID DUA1. Okay, there we are. Set def dot TCP/IP underscore vax051 dir setdef dot kit dir, and then we'll do product. This is a PCSI installer, so we just do product install star. Yes. Yes. No. Just take the defaults here. Takes a couple minutes, but it's not too bad. Okay, let's make sure that that IP address that we wanted to use is available. So that IP is 10.0.0.191. Go back here. No ping response. So I think we're good there. So now we do as they suggest and run this script, this DCL script right here. Configure all options. Options 1 through 5. My domain is chivanet.org. Configure interface manually. And this is aries.chivanet.org. .0.0.191. We're using that as a class C. And then, okay. We don't want to define an internet VMS cluster. Don't want to run any IGPs or EGPs. We want a default route, and that's 10.0.0.1. I'm not going to define a host name for that. Set up our DNS servers. That's all. Okay. That's the core stuff. And then, let's see, what clients do we want? We want FTP. Enable service on this node. Don't want to do that yet. Then NFS client. Yep, I'm going to do that. Got a lot of Unix running here. And then I want Telnet. Enable on this node. That's all for clients. For servers, let's see. I'm going to enable FTP. It's useful to be able to transfer files. Enable service on this node. Don't want want to configure FTP client. We already did that. Then let's see. I think I want port mapper because that's required for NFS. Let's see, I want, okay, telnet's enabled. No, I do want NFS server. Enable service on this node. And then I want SNMP. Enable service on this node. Yes, I want to enter new SNMP configuration values. Don't want to allow modify access. Yes, I want authentication traps. No to the public community. Yes to additional community names. And then this is going to be for read and trap. And then my NMS is that address. Don't need any others. Don't need any others. Then the location is VM ESXi 03 ultimately. And then that's it for that. Don't need any of these, not doing pathworks yet. And now, let's start it up. Starting all the services. Now we can exit the configuration procedure. Yes, go ahead and start the services. Well, they're already started. That was weird. Okay. So let's edit sys dollar startup sy startup vms.com. And we're going to make it so that TCP/IP starts automatically when the system starts. And that's going to be after DECnet. And it's this one, because we're on TCP/IP, not UCX, the newer product. And now, I think this host is good to go. Let's do a reboot. Just make sure everything comes up normally. It's thinking. Here we go. Our CPU usage is pretty high. Join the cluster. Now we'll mount those disks, the shadow sets. First one done, second one done. Should start DECnet pretty soon. Yep. Circuit came up. TCP/IP is starting up. Found an adjacent DECnet node, starting the TCP/IP services. LAT's coming up. Whenever it gets around to it, it should let us log in. There we go. Okay, we're in. So let's do show cluster. And there we are. 1, 2, 3, 4, 5, 6, 7, 8 nodes now. So I think that's pretty much it. Oh, I did want to check the common authentication stuff. Yep. That's my user account that I defined elsewhere on the cluster, so yep, and all my stuff is there. So I think we're set. I hope this video is of some interest and use to everyone. Please feel free to leave a comment and enjoy the rest of your day.